Hey everyone, Mr. Skelton here. We are back at it, lesson 4 in unit 11. Today we're going to be talking about the normal curve, or what we refer to as the bell curve. And really, it's an application of standard deviation. We can make this really complicated, but I'm going to try to keep it very simple for you. The normal curve is just a way to look at and evaluate data or observations within a data set. And what we did in lesson 3 was talked about calculating standard deviation. And with the normal curve, it allows us to apply standard deviation so that we can look at data a little bit more specifically. That's what we're doing, okay? There's a couple problems at the end where we're going to answer some questions and do some basic math, but at the end of the day, we're just trying to look at the bell curve and apply standard deviation to it. So, data, as you know, can be distributed in many ways, all right? When it's not, this is the standard curve, or the normal curve, what we call the bell curve. For the most part in life, most data that is collected fits this. That's why the bell curve exists. You do have certain situations in life where data can be skewed. Some to the right, where there's a heavy population to the right, heavy population to the left, or it's just all over the place, okay? But most of the time, any piece of data that is collected, the observations can be fit within what we call the normal curve or the bell curve, okay? Just show you some real quick examples. We did, this isn't in your notes, but yesterday, I already drew on this one, so I apologize. But in lesson 3, we talked about dogs, right? And we had some of the dogs' height, I believe. Well, this one's dealing with weight. So this is just a histogram. Most of you know this is a histogram or bar graph. You have the number of dogs here, and you have the weight at the bottom. So real quickly, there was 35 dogs. The majority of the dogs in this data collection fell between 30 and 39 pounds. That's the average. That's the norm. And then we had some dogs that were slightly bigger. We had 16 that fall within 40 to 49, and then 24 that were slightly less. And yeah, it's not perfect, but you can see this curve, this bell curve of the data that it takes on. Okay. Another one that's very popular is grades. Your grades in high school, your grades in middle school, anything that has the 0 to 100 scale. Here's your students. Where do most students fall? Well, 20 of the students fell somewhere in that C range, right? 77, 78, right in the average there. Then we have kids who do really well in the 90s. We have kids who do in the 70s, and then there's some kids who bomb, and there's some kids who get A++. And those are the extremes. That's why it's so small. There may be just one student down here who was in the 100%, or 2 students, whatever the case may be, but that bell curve. The last thing that's very common, and it's actually, I know I'm jumping around on your notes here, is on this, and we'll talk about this later, but IQ. IQ testing is actually these scores right here. If you have a IQ of 100, you're right in the middle. You're right in the average, the mean. And then the standard deviation for IQ is 15. So from 100, you go from 100, you add 15. That you're within the first standard deviation. This is one standard deviation below, which actually what we're going to talk about next, which is the standard deviation. But I wanted to start off by basically talking to you about just how most data falls within this bell curve, or what we call a normal distribution of the data. Okay, let's keep moving a little bit quicker. I already talked about this. I talked about many things in life that follow normal distribution that fit this curve. The heights of people, error in measurement, blood pressure, test scores, IQ scores, which I just talked about. So the nice thing about the bell curve is that it is symmetric, all right? And so you have the middle ground, or the average here right in the middle, usually referred to it as the mean, and 50% of the data will fall to the right of the mean, and 50% of the data will fall to the left of the mean. You already know that. So here's how standard deviation comes into play, and this is important. 68% of most data that follows the standard or the normal curve in normal distribution 68% of the data falls between one standard deviation of the mean. So what does that look like? Well, this can be represented in a lot of different ways in terms of the percentages, but we're going to round it to kind of keep it nice and neat for you. So here's what I want you to write down, and here's what I want you to use moving forward. So remember, this is the mean. Well, as you see the +1 here and the -1, that means one standard deviation. 68% of values are always within one standard deviation of the mean. So that means 34% is the +1, 34% is the -1. So one standard deviation away greater than the mean is 34%. 34% makes up your 68. Okay. 95% of the population values fall within two standard deviations of the mean. So these percentages that I want you to use, so two standard deviations, right, would be 13.5%. So that's a 13.5%. And this would be 13.5%. That's -2. If you add 13.5 plus 34 plus 34 plus 13.5, you will get 95%. Okay? And then the last one, we're actually going to go to 100, so we're not, it says 99.7, we're just going to make it a nice, neat 100%. We're going to say, for us, for what we're doing, not 100% of the values fall within three standard deviations, and that's not perfect, but +3 would be 2.5%, and then 2.5% here, -3. And if you add 2.5 plus 13.5, 34, 34, 13.5, 2.5, you will get the 100%. Okay? So that's how standard deviation is applied to the normal curve. So this picture that I showed you is in much more detail, in greater detail. These are a little bit more precise percentages away from the average. So basically 68.26% of data falls within one standard deviation. You can see the standard deviations here, +1, -1. And then you have the 13.59%, 13.59% here. So all, whatever that adds up to, that decimal, is within two standard deviations of the mean. And then you have three standard deviations, includes the 2.14 and 2.14. And then and this curve has four standard deviations, so a small percent, 0.13%. Percent of the is four standard deviations away from the population. Okay. There's I may be able to show you in class, but there's a lot of websites where you can do like an online IQ test, right? And you can kind of see where you fall. 100 being the average, the middle, and you can see where you fall within the standard deviation, because the standard deviation of IQ is 15. 15 below, 15 or 15 above is 115. 15 below is 85, and you can just add 15 again, makes 30. You get the idea. Okay. So what we're going to do is, there's some questions, and you can see right here we have this situation. And what we're going to do is, with these questions, we're going to apply this curve. So this is the curve that I really want you to know moving forward. I'll put a big star next to it. Those are the percentages you're going to have to be familiar with. When I give you the test, whether it's a half test or full test, you're going to have to know these percentages and then how to apply them to the problems, okay? So let's just do it. All right. We got, it says for each question, basically construct a curve and label it so that you can kind of follow along with the information that's provided to you. So let's take a look at it and we'll go from there. The mean life, that's important, of a tire is 30,000 kilometers. So what I'm going to do is draw a decently good sized curve here so that I can label it appropriately. So I'm going to put right here in the middle, 30,000. Okay, that is the average. That is the mean. I'll put a little squiggly line on it just so to differentiate it from other lines. The standard deviation is 2,000. So plus one standard deviation away, we know is going to be 32,000. So that's plus one standard deviation. That's 34% above the mean. So 34% above 50% is 32,000 miles on those tires. Okay, I can go we'll go another one. So plus 2, so that would be 34,000 miles, and that's the 13.5%. And then we're just doing to 3, 2.5%. and that would be 36,000 because the standard deviation is 2,000. So every standard deviation you're adding 2,000. Well, we need to go the other way as well. So now I'm going to subtract. That's going to be 28,000. So remember, this is always basically 50%, right? If you add up these, that should be 50%. Add up with these, 50%. So 34% below, it's minus 1. Standard deviation is 28,000. And then 13.5%, that's going to be 26,000. And the last one is a minus, so that's minus 2, so minus 3 is 2.5%, and that's going to be 24,000. Okay, so now that I have the situation graphed on the bell curve, let's take a look at questions A, B, C, and D and see what we can figure out. 68% of all tires will have a life between what and what? Well, remember, 68% is the 34 and the 34, so numerically speaking, that's 28,000 to 32,000. So 68% of these tires will have a life expectancy between 28,000 kilometers and 32,000 kilometers because 34 and 34 make up the 68%. 95%, now, you may or may not recall what the 95% is. If you need to go look at your notes, just flip back a page. Remember, remember, one standard deviation away is 68%. That was the first question. Now I'm asking you about 95% of the population. Well, what's 95% of the population? That's 2 standard deviations away. So you come back to your curve here. Basically, 2 standard deviations away, 26,000 and 34,000. So 26,000 and 34,000. Okay. What percent of the tires will have a life that exceeds? So a life that will have more than 26,000 miles. Well, that's this, 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 and this. So you could add all those up, 13.5 plus 34 plus 34 plus 13.5 plus 2.5, or you could just take 100%, because remember we made this make 100%, and just subtract the 2.5, and you should get, let's see, let's do, we'll add them all up. So 13.5 doesn't matter, plus 34, plus 34, plus 13.5, plus 2.5, we should get 97.5%. Okay, we could have easily just went 100. I'm on my calculator in view. I should have done that. Sorry. 100 minus 2.5, 97.5. Okay. Last one. If a company purchased 2,000 tires, how many tires would you expect to last more than 28,000 kilometers? Well, what's more than last more than 28,000? So that's 34, 13.5, 2.5. So let's add those up. 34 plus 34 plus 13.5 plus 2.5. That's 84%, right? So basically 84% of the tires we think should last more than 28,000 miles. So how do we figure out, because it doesn't say the percentage here, it says how many tires. So we take 84% of 2,000. So how do we do that? Well, we change 84% to a decimal, and we just times it by 2,000. So 0.84 times that by 2,000, and we get 168. That should be our answer. Okay. Last set of questions, very similar to what we just did. Why don't you hit pause, try this, and see what you come up with. All right, so monthly income, 5,000 workers at the Microsoft plant are distributed normally. Suppose that the mean is 1250. So let's draw like we did before, big bell curve here, space it out a little bit. I'll do a little squiggly line just to differentiate, and there's my 1250, okay? The standard deviation, well, very important, is 250. So now I have to make my rest of my graph like I did before. So this will be 34% this way, and that's going to be 1,500. That's my +1 standard deviation. This will be 13.5%. That's going to be 1,750. It's +2 standard deviations, and then 2.5% should give me an even 2,000. That's plus 3 standard deviations. So to the left, 13.5%. I'm subtracting 250, so that's 1,000. Oops. Sorry, that's 34%. That's a minus 1 standard deviation, 34%. And then this is 13.5% minus 2. That should take me to 750. Remember, I'm just adding and subtracting 250 because that's what the standard deviation is. And then 3 standard deviations away to the left would be 500. So that's what I would want to draw before I even start. Let's answer some questions. So how many workers earn more than $1,500 a month? Well, we got to figure out the percentage of people that earn more than $1,500 a month. So here's the 1,500. So 13.5 and 2.5. So I'd go 13.5 plus 2.5. That's going to give me 16%. So what do? I take 16% and I times that by 5,000, just kind of what we did in the last problem. So 0.16 times that by 5,000, 1, 2, 3. That's going to give me 800. So 800 workers. Okay. Part B, how many workers earn less than $750 per month? This was 2.5%. So how many workers earn less than that? 2.5%. So 0.025 times that by 5,000 workers. It's going to give me 125. Okay. And part C, what percentage of the workers earn between 750 and 1,500? Add up the percentages. 34 plus 34 plus 13.5. I should get 81.5%. What percentage of the workers earn less than $1,750 a month? That's going to be basically, that's $1,750 a month. So what percentage of the workers earn less than that? That's going to be basically 13.5, 34, 34, 13.5. So basically 100 minus the 2.5. And I get 97.5% earn less than $1,750 a month. Okay? So you do see a lot of repetitive type questions that you're going to be dealing with. Again, it all boils down to knowing these percentages, being able to take the question, label things correctly, and just dissect the question and figure out some percentages and some numbers. Okay? So that's how we kind of apply standard deviation to the normal curve. Hope you enjoyed it. And as always, if you have questions, I will answer them in class. Take care. See you.